Yakubu from Hope Academy Schools, SS2, and with me today are my mates.
Jan Victor Chun.
Osai Faith.
We
are here to demonstrate an experiment on rate of chemical reaction. What is rate of chemical reaction? Rate of chemical reaction is the speed at which a chemical reaction proceeds. The rate of chemical reaction can be determined by monitoring the following properties of a reacting system, such as color, change in mass of reactant, pH, temperature, volume of gas evolved, turbidity, and pressure. In this experiment, the evaluation of gas will be taken into consideration. I will now hand over to my mate Victor.
Thank you. The materials needed for this experiment are dilute hydrochloric acid, magnesium ribbon, reacting vessel, syringe, stopwatch, graph sheet, and our writing materials. Before we start the practical, it is good to know the theory of the experiment. This is magnesium in a solid form and dilute hydrochloric acid in an aqueous form. Magnesium reacts with the dilute hydrochloric acid in the following way. As the reaction proceeds, magnesium and dilute hydrochloric acid are used up, while magnesium chloride and hydrogen gas are produced. Now, we start our practical to determine the rate at which hydrogen gas is produced. Procedure. Step 1. Fill the reacting vessel with dilute hydrochloric acid. Step 2. Insert the gas syringe through the lid of the reacting vessel. Before step 3, we need to draw our table of value and get our graph ready. Here, time is in seconds while volume is in centimeter cube. While here, volume is in centimeter cubes and it is on the vertical axis, while time is in seconds and it is on the horizontal axis. Step 3. Put a cut piece of magnesium ribbon inside the reacting vessel and quickly cover it with its lid. Before we start, my mate will be recording our values at an interval of 2 seconds. As you can see, hydrogen gas is being formed in the syringe. The rate is not uniform over the whole reaction. The reaction rate is highest at the start of the reaction and decreases gradually with time, becoming 0 when the reaction is completely used up. Now our reaction is complete. We will now work with our table of values on our graph. Here is our table of value and here is our graph. Our volume is on the vertical axis while our time is on the horizontal axis. Now we plot our graph. The rate is not uniform over the whole reaction. The reaction rate is highest at the start and decreases gradually with time becoming 0 when the reaction is completely used up. From our graph, the total volume of hydrogen gas produced is 9.6 centimeter cube. The equation of our reaction is this. Mathematically, rate is given as volume over time. Here, the total volume of hydrogen gas produced was 9.6 centimeter cube, while the maximum time was 20 seconds. So therefore, rate is equal to 9.6 centimeter cube over 20 seconds, which is also equal to 0.48 centimeter cube per second. Therefore, the rate at which hydrogen gas was produced is 0.48 centimeter cube per second. Thank you.